Hello, we are the team behind SQLatte, a coffee e-commerce platform designed as a part of our story and retrieving data final project. Our team is composed of João Paulo, Lucas, Gonçalo, and Leonor. Through the presentation, we also explained the design choices made to ensure data integrity, proper cardinality, and compliance with first, second, and third normal forms. Okay, starting with the customers. Customers table stores the core customer's identity and login information. Each customer has a unique customer ID, an email used as a login, a hashed password, full name, phone number, and a creation timestamp. One customer can place many orders, write many reviews, and have multiple addresses. So the relationship between customers and orders, review, and addresses is one to many. Countries. Countries table is a lookup table that stores the country code and the country names. Addresses. The addresses table stores shipping and billing information for customers. One customers can have many addresses. One address belongs to exactly one customer. Is a one-to-many relationships. Categories. Categories tables define product categories such as coffee beans, equipment, and accessories. One category can contain many products, but each product belongs to exactly one category. Is a one-to-many relationships. Brands. The brands table stores product manufacturers. One brand can be associated with many products, again, a one-to-many relationships. Products. The products table is a central product catalog. Each product references a category and optionally a brand, and the story is its name, description, price, stock quantity, active flag, and creation date. Price is stored as a decimal to guarantee financial precision. Product attributes. The product attributes table stores flexible attributes. Different product types requires different attributes. Instead of adding many nullables columns to the product tables, we store attributes in a separate tables. One product can have many attributes, a one-to-many relationships. Coupons. The coupons table stores discount codes used in promotions. Each coupon has a code, discount value, discount type, expiration date, and active flag. One coupon can be used in many orders, but an order can have at most one coupon. It's a one-to-many relationships. The discount type is an enum, ensuring only valid discount times are allowed. Orders. The order table stores the order header information. It references the customer who placed the order, the shipped address, and optionally a coupon. One customer can place many orders, but each order belongs to exactly one customer. It's a one-to-many relationships. Customer's name or email is not duplicated here. We store only customer ID, which avoids redundancy and supports the third normal form. Order items. The order items table stores individual product lines within an order. An order can contain multiple products, so this table resolves the many-to-many relationships between orders and products. One order can have many order items, and one product can appear in many order items. Each row represents a single product in an order, ensuring atomic values and the first normal form. Reviews. The reviews table stores customer ratings and comments for the product. It satisfies the requirement that customers can rate products. One customer can write many reviews, and one product can receive many reviews, both one-to-many relationships. Transaction logs. The transaction logs stores an audit trail of important system events. Overall, this database follows the three normal form. Each fact is stored in exactly one place, which reduces redundancy and prevents update, insert, and delete anomalies.
The first trigger relates to logging the orders. So basically, every time that we insert a new order, we must also insert a new row in the transaction logs table. So first of all, let's see how it looks like this table after the database generation, the first generation. So we have order ID with 30, status canceled, and so on. So I will insert a new one. After this insert, you can see that now we have a new order, order 31, which is pending. So let's see if the trigger worked. Basically just run this. So running this, I can see that a new log has been placed with log ID 31 and order ID 31. The second trigger relates to updates in the orders. So basically, when we set the status, when we change the status for an order, we must also insert a new row in the logs table. So I'll update order 31. Check how it is now. So now the status here is shipped. So this query should return me another row in the transaction logs. So here we have log ID 32, order ID 31, and then the action type order updated, which means that the second trigger is working. The third trigger relates with stock. So basically, every time that one order is being finally processed and paid, we must decrease the number in the stock. So let's check how is the stock for one product after the database generation. So this is one product, Delta Gold Blend, and it has initial stock of 100. So I'll insert a new order for it. Insert a new row in order items, which is the linking table. And this will, in this order items, I can see here that the quantity is 5. So after updating this order to paid, the trigger must the quantity to 95. So update it, and then I can check the stock. So as you can see, after the the trigger here is working. There is 2 views, one view for invoice header and another view for invoice lines. And if I query invoice header for this invoice number, I can see all the data related to that invoice, like customer name, customer city, and so on. Also company name and all the header information in the invoice. And now for the invoice lines, when I run this, I should see all the descriptions and all the products inside that invoice. Invoice number 1, the description contains 2 products, a Delta Gold Blend and this one with these quantities and this amount of money.
To conclude our presentation, we developed 5 advanced analytical queries that simulate real-world business decisions. Our first query identifies our top 3 revenue-generating products. We then joined these with our customer data to find our most loyal users. We used group concat to list which of these top products each customer bought. Next, we analyzed our promotional strategy by joining our orders with the invoice header view. We compare the success rate, which is the delivered versus canceled, of orders with coupons versus those without. This helps us understand if discounts are actually driving successful sales or just attracting low commitment orders. For the management team, we built a 24-month revenue trend analysis. This query extracts the year and month from the created at timestamp. It's essentially for identifying seasonality in coffee sales and planning for yearly growth. We also implemented a top 10 customer ranking based on lifetime value by filtering only for paid, shipped, or delivered statuses. We ensure that our customer lifetime value calculation is accurate and based on actual realized revenue. Finally, we created a predictive inventory query. It calculates the average sales per day over the last 90 days and divides the current stock by that rate.